many of us here have probably heard of or played the game Minecraft. And for those of us who haven't, Minecraft is a game which takes place in a world built entirely out of pixels, and the main character, Steve, explores this pixel world. But what you're looking at right now isn't Steve in Minecraft. It's actually Steve inside someone's brain. In brain imaging, those pixels are called voxels, tiny 3D blocks that map our anatomy. Most of the voxels in our brain contain nerves. My research looks at the trigeminal nerve, which carries pain, touch, and temperature from our face to our brain. We have two of them, one on each side. In a condition called trigeminal neuralgia, a nearby blood vessel starts to press on this nerve, triggering unimaginable pain. When I've asked patients to rate it out of 10, they say 15. To look at the hidden damage, we can look at what the brain is mostly made of: water. When a nerve is healthy, water flows through it smoothly, like a calm river. But when a nerve becomes damaged, that flow becomes chaotic, like whitewater rapids. Using a special type of brain imaging called DTI, I track how that water moves in every voxel. And just like Steve exploring his pixel world, I explore these voxels until I find the trigeminal nerve, those bright green voxels you can see. Water measurements have shown me two surprising things in them. One, even though patients usually feel pain on one side of their face, both nerves show these chaotic water measurements. This disease isn't just a local pinch, it's reshaping our brain's entire wiring. Number two, in patients who have surgery where that blood vessel is moved away, those patients whose pain goes away show a permanent change in their water measurements. But in patients whose pain comes back, their original measurements return. In other words, we can see who will remain pain-free after surgery, and even more importantly, we might be able to see pain before a patient can even feel it. But the trigeminal nerve doesn't end at these bright green voxels. In fact, it pushes even deeper into our brain, into a region called the brainstem. The brainstem is where pain is processed for the first time, but it's also a dense, tangled forest filled with thousands of nerves, making it harder for us to see the trigeminal nerve. But we are already pushing into that forest, developing and improving our brain imaging strategies, not just to learn about this one condition, but to understand the very biology of pain itself. I'll always be a big fan of Minecraft, but instead of building worlds out of voxels, I'm dedicated to learning about the ones that shape the reality of human pain. Thank you.